So as we continue our conversation about triangles, we move into the Triangle Sum Theorem. And the Triangle Sum Theorem is probably something you're familiar with, but again, you probably are not familiar with it by name. And all the Triangle Sum Theorem says is that for every triangle, the sum of the measures of all the interior angles, and there'll be three of them, because it's a triangle, right, will be 180 degrees. So I think you probably might remember that from a prior math life, but we're going to go ahead and prove that, and then we're going to do a couple of examples that utilize that, okay? So let's start with this one. Let's say we're given triangle CAT, and we also know that line P is parallel to line Q, like in this drawing, okay? Here I have triangle CAT, and I also know that line P is parallel to line Q. Notice that the lines have these triangle markings on them. Remember, that tells us that the lines are parallel. Okay, so we want to take that information and run with it, and then be able to prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 4 is equal to 180 degrees. Ready to rock and roll? Let's go. All right, remember that with outline forms of proof, we are almost always going to just start by telling what we know. Okay, so what are we given and why? So let's go ahead and write down our given statement because it's given. Ready? Okay, so now we know that much. Now what we're going to do is take a look at this drawing and see what it is we know from the drawing. So let's take a look. What do you know from this drawing? The first thing that comes to mind is these angles. Do you see these angles? Well, if I fit them all together, they make a line. So that means when I add all the sums together, I should end up with 180 degrees. And remember that when we add the sums of two angles that are next to each other and we get the sum of the whole thing, that's called the angle addition postulate. So I can go ahead and write that relationship. So the measure of angle 3 plus the measure of angle 4 plus the measure of angle 5 will equal 180 degrees by the angle addition postulate. Okay, voila. Here we have the statement just like we said. And there's our reason. All right, so now what can we do with that? Now we're going to go back to what we talked about earlier with lines cut by a transversal. Okay, do you see a transversal here? It's kind of hiding, right? Because we actually have this triangle in between two parallel lines, and we can actually extend those lines if we needed to. In this case, we really don't, but we also have one over here. And since those lines are parallel, that tells us something about these two angles and those two angles, because we learned that if the lines are parallel, alternate interior angles will be congruent. That's called, big shocker here, the alternate interior angle theorem. All right, so we're going to state those two things, and then we're going to take two lines to do that because they're two different things. Okay, take a look. Angle 5 is congruent to angle 1 by the alternate interior angle theorem. Angle 3 is congruent to angle 2 by, again, the alternate interior angle theorem. Okay, so, can you see where we're going with this now? It's not too terribly difficult. Okay, so now we can kind of combine these two things and make some substitutions, and we should end up with our result, okay? Here we go. Right, so we took and we substituted the measure of angle 3 for the measure of angle 2 because angle 3 is congruent to angle 2, which means their measures are the same. We could have taken a separate line and called that the definition of congruence, made these into equal measures, but didn't do that, okay? We have measure of angle 4 the way we want it, and then we changed out the measure of angle 5 for the measure of angle 1, okay? And so we said the measure of angle 2 plus the measure of angle 4 plus the measure of angle 1 is equal to 180 degrees just by substitution, okay? And then lastly, we just rearrange the order of these by the commutative property of addition. And then we have our nice little proof saying, hey, the measure of those interior angles is equal to 180 degrees. All right, so let's look at a couple of examples of problems where we've got to utilize the triangle sum theorem. All right, here we go. Let's start with this one up here. We actually have two triangles sitting butted up against each other, right? And they share a common vertex. So we are wanting to get to this angle, but we're going to have to use this angle first. And think of these as like a great big puzzle. We want to kind of work our way around to the angle in question. Now, you might be tempted to say, well, these are parallel lines, so I can use alternate interior angles there. Well, are they marked parallel? They sure look parallel, but they're not marked parallel, so I can't actually do that. So let's use the triangle sum theorem. Ready? We have 20 degrees and 40 degrees here, and the sum of these needs to be 180 degrees. So that means I've got 60 degrees accounted for, and I've got how much left? 120 degrees, right? Awesome. Now, how do I get into that other triangle? Ooh, that's a vertical angle. When you've got two lines that are crossed like that, the angles that are across from each other are vertical angles, and that means they're congruent. So I can just hop across into the other triangle. That's always the case. All right, and we now are ready to solve for the angle that we need. So I have 120 degrees here and 39 degrees there. I think that's 159 degrees accounted for, and I need 180. So what's left? Well, I believe that will be 21 degrees. Aren't these fun? Here I've got two triangles adjacent to each other, and if you put two of the angles together, you get a right angle. So we're going to use that. We're going to start with this triangle here. You're always going to start with a triangle you've got 2 with a 3 in, if you have such a thing, all right? So we know that this triangle has 2 of the 3 angles that I need. Now this angle right here, we don't know what the measurement is. All we know is the measurement of the sum of those angles is going to be 90 degrees, okay? So we've got this 84 degrees and 36 degrees, and we are going to add those together, and you're going to put your thinking caps on, and you're going to say 84 plus 36, 120 degrees. Okay, 120 degrees, and so what's left for this little piece right here? I think that should be 60 degrees. Now we know that in total, this angle plus this angle will equal 90 degrees by angle addition postulate, right? And so we know then that we can find this one to be 30 degrees. And now I can work my way around to the angle that I'm looking for. I have 86 degrees plus 30 degrees. That's 116 degrees. I need 180 degrees. So where do I go from there? I think we're up to 64 degrees. What the heck is going on here? There's a lot happening. Okay. So I want to get all the way over to here. And I said before, you're going to start with a triangle that you have 2 angles with. Except I don't have one of those here. So I want to think about, well, what do I have? And I have a couple of angle measures that are directly outside the triangle. In other words, the measure of the angle that forms a linear pair. And I know that these 2 angles are going to be supplementary, as well as these. So I can calculate what this angle is and this angle is by just taking the supplement or subtracting that measurement from 180 degrees. So if I subtract 115 degrees from 180 degrees, well, that's going to be 65 degrees. And if I subtract 155 degrees from 180 degrees, well, that's going to be 25 degrees. All right, now where do I go? Well, now I've got a triangle that has 2 of the 3 pieces, right? So I've got 65 degrees plus 85 degrees. If I add those together, I think that's 150 degrees, which leaves the remaining angle to be 30 degrees. All right, now how do I get over here? Well, do you see these 3 angles? they fit together and form a line. They're not a linear pair because there's more than two, but when I fit them together, make a line, I can say that the sum of their measures is going to be 180 degrees. Okay, well, I've got 30 degrees plus 90 degrees, also known as 120 degrees. And what's left over here is 60 degrees. 60 degrees plus 25 degrees is going to give us 85 degrees, which means this angle here is going to be 95 degrees. And that's going to give us the clue that we need to get to this angle here. Remember, that's a linear pair, so I can subtract that from 180 degrees to find what I'm looking for. I think that gives us 85 degrees. All right, the last one is a little bit different because I don't have a lot of angle measures. What I have is an angle measure here and some expressions there, but I have all three angles represented. So I can think about what does that triangle sum theorem say, and it says, well, the sum of the measures of the three angles will equal 180 degrees. So I could just take the three of these angle measures, sum them up, and set them equal to 180 degrees, and that should allow us to solve for x as well as the two angles that I don't know. Okay, let's give it a shot. Okay, so I have x plus 59 degrees plus x plus 51 degrees plus 84 degrees equals 180 degrees. Now I have some simple algebra, which allows me to collect like terms, and solve for x. So when I collect like terms, I have two x's here, right? So I have 2x plus, let's see, 59 degrees, 59 plus 51 plus 84. 59 plus 51, that's 110, plus 84 is 194. 2x plus 194 is equal to 180. All right, subtract that 194 out, and we should get 2x is equal to negative 14, which means that x will equal negative 7. Now, is that okay? Is it okay for x to be something negative? We never deal with negative angles. Well, yes, x can be negative 7. When I sub it into the angle measures, I'm going to get something positive. Okay, so let's put it here. Let's put that negative 7 in here. We would end up with this angle measure is equal to 52 degrees. And if I put a negative 7 right here, I get this angle measure is equal to 44 degrees. And let's just do a quick double check. 52 degrees plus 44 degrees plus 84 degrees. Does that equal 180? Well, I'm going to do some quick mental math. 50 plus 40 is 90. Plus 80, that's 170. Now let's add the change, the ones. 4 plus 2 plus 4, that's 10. So I've got 170 plus 10 is 180 degrees. That's exactly what I wanted. Perfect. All right, next video, we're going to talk about exterior angle theorem. It's really kind of an extension of this.